Okay, welcome back. So for this example, we will focus on multiplication and division. To do that, we could use an example with a couple integers and then a couple floats, and then we'll mix them up to see the behavior of float or integer multiplication and division. And hopefully we'll also get to see some typecasting, which means modifying from one data type to another within the realm of numbers, okay? All right, so let's get started. So let's say I have two variables, num1 and num2. And let's say I also have something to store the result. Now, these are all integers, okay? So we could set values for either one. So num1, let's say, is equal to 7 and num2 is equal to 9. Then a multiplication of these two, the content of these two variables would look like this. Result equals num1 times num2. Okay? Right? So you can go ahead and printf. And then we could put a %d here just to give us a placeholder where to print num1. And we're going to do times, or you could do a big X here. It doesn't matter. You're not doing the operation right here. So another %d equals, now the result also is going to be an integer. So let's go ahead and put a new line here. That would be num1, comma, num2, comma, result. Okay? All right, so they're going to come out in that order. So let's compile and run. Oops, compile and run. And let's see where we're getting an error. And it says result. Did I spell it the same way? Ah, right there. Result. Forgot an L. Right. So good. So let's compile and run. And there you have it. All right. So 7 times 9, you get 63. Press any key to continue, and we're good. Right. Our press any key to continue is done with getCH function that is defined in this library file. Okay, so I've done this instead of system pause, just in case you're on a different platform. Okay, well, let's do a division. Let's do an integer division. Now we could do it in the printf statement itself, or we could change the result if you want. So %d divided by %d equals %d. The result is an integer, /n. And so let's go ahead and do num1, num2, and for the result, you're going to have to do the division right here, num1 divided by num2, right? So we're doing the operation right here instead of an intermediate variable like result. So you can do operations right in the printf statement. So let's see how this works for us. So we're dividing num1 by num2. So compile and run. And sure enough, you're going to get 0. Now, you would say, well, wait a minute. 7 divided by 9 should give us a 0 point something. Well, this is an integer division. So it's not going to yield a float value. Okay? Is there a workaround this where we can divide two integers and get a float? Yes. Converting the division itself to a float is not going to make a difference. So that means if you made result float and you divided 7 by 9 as integers into it, you will still get, let me prove the point. So let's say I do this. Float result 2, right? So we have two results, and let's redo the division again. So let's go ahead and do result 2. Now remember, now result 2 is a float, right? Num1 divided by num2. So same division, and we're going to print the result. So printf, okay? And so result stored as a float value And let's see if it actually percent point 2f, let's set it up to 2 decimal points, /n, and that would be result 2. Now, I need you to pay attention. We're not going to get the correct result, and there is a good reason for it. So let's compile and run. And you will still get 0, even though result was a float. And that is because you still had an integer division on the right-hand side, which yielded that 0. So what? You converted 0 to 0.000. So you converted the 0, which was an integer, into a float, but it was too late. So is there a work around this? The answer is yes. You can actually convert either num1 or num2 or both as float values to get a float value. So let's do that. So we could do it in the printf statement, just show you what it would do, printf. Okay. Convert num1 or multiply. First, let's do this, multiply, and then we'll do a conversion. We'll do it what we call a typecasting. Multiply num1 by 1.0. So you're going to multiply by 1.0, then divide. Right? So result equals, and that would be a %f. So we want a result come out as a float, %.2f /n. And here's what you're going to do. You're going to take num1 times 1.0. So you're multiplying it by 1. Num1 happens to be 7, so now it's 7.0. The result of that multiplication divided by num2. You can leave the denominator as an integer. Num1 in this case did not change. It's still an integer. But the numerator for this division is now a float value. You divide a float by an integer, you're going to get a float. So now we're going to get a result that is close enough, compile and run, okay, to what we want, 0.78. Okay? All right? So that is the correct result typically if you were dealing with real numbers. 7 divided by 9 will give you 0.78. Is there a way or another way to do this? Yes. Printf. We're going to do what we call typecasting num1 into a float. And result equals, and again, %.2f. So we're going to keep it at 2 decimal points, /n. Now notice how I do this. Float num1. That's going to convert num1 into a float. Then divide by num2. Okay? And we should get the same result as if you multiplied by 1.0. This is what we call typecasting. So it will temporarily change the numerator, num1, into a float. I think I still have the display of my previous result. Let's go ahead and compile and run. And there you have it. So now we get 0.78 obtained by multiplying num1 by 1.0. And we also got 0.78 by typecasting num1 into a float. Okay? So these are two good valid techniques for division in case you have two integers in the numerator and the denominator. Now, is it always a bad thing? No. Sometimes you want an integer division. Okay? So there are situations where an integer division is desired. Okay? All right. So, but the work around it, if you really want to get the result of what is 7 divided by 9, as if you would do it on your calculator, then one of the members for the division has to be a float. Okay? And one technique is if you multiply a float by an integer, you get a float. So that should give us an idea, some of the properties of multiplication. If you typecast, which means you change the data type of a variable into something else right here, while in here temporarily, num1 is still an integer, but temporarily during this operation, during this process, this numerator would be considered a float.